Earth life. Huh. Why does that look like blue, or just my eyes which make me feel like it's looking like a blue? I'm looking like a blue? Maybe. Okay, let's just start again. So, in earlier that we were here around 5 till 5 o'clock. So now after around 3 or 4 hours we're back, and let's just try to complete the chapter. And yes, I haven't slept whole night, but I think I'm gonna sleep after this. Okay, let's see what is happening. Give it some thought. Which quantity is the smallest one? 1 mg, 1 microgram, or 1 picogram? So 1 picogram is the smallest one. We all know that. Okay. Now we will learn length and mass. I think I don't like the slide, so let me just do a little bit experiment and see if. Ow, sorry. How does it look like now? I don't care. It's okay. So length and mass. The SI base unit of length is the meter. The SI base unit of length is meter. A distance slightly longer than a yard. Distance slightly longer than a yard. I don't know what is that because we don't use that. Mass is a measure of amount of material in an object. Okay, get it? The SI based unit of mass is the kilogram. The SI based unit of mass is kilogram, kg, which is equal to about 2.2 point. Okay, so 1 kg is equal to 2.2 pound lb. This base unit is unusual. This base unit is unusual because it uses a prefix kilo instead of the word gram alone. This base unit is unusual because it uses a kilo prefix instead of word gram alone. We, excuse me. We obtain other unit of mass by adding prefix to the word gram. Okay, I get it. Sorry. Okay, so sample exercise using SI prefix. What is the name of unit that equals? What is the name of unit that equals 10 to the minus 9 gram? I think this is called nanogram, and 10 to the power 6 seconds, milli microsecond, and 10 to the power minus 3 meter is millimeter. You can find prefix related each other. Power of 10 in table. First one is nanogram, that's correct, ng, and then microsecond, and then millimeter. Yeah, you're right. Mass and weight are often incorrectly thought to be the same. Okay, so mass and weight are not same. Okay, weight of an object is the force that is ex- exerted on its mass by gravity. Okay, in space where gravitational force are very weak, gravitational force are very weak, our astronaut can be weightless. Yeah, definitely, but he or she cannot be massless. The astronaut mass in space is the same as is in on Earth. Okay. Hmm. So there is difference between mass and weight. Weight is measured by basically applied gravity, and is mass. Cause just like they explained it right now, with the any object or maybe astronaut goes into the um, gravity-less field, like the universe, but they feel like they are weightless because there is no gravity. So weight defined by the gravity. Okay. Practice exercise. How many picometer are there in 1 meter? How many picometers are there in 1 meter? Huh, picometer. Pico come before femtometer. 10 to the power 12. Yeah, I was right. 10 to the power 12. So how many picometers are there in 1 meter? How many picometers are there in 1 meters? 10 to the power 12 picometers express 6.1 into 10 to the express 6.0 into 10 to the power 3 meter using a prefix to replace the power of 10. Okay, I did not get this question, but you can express 6 meter using a prefix. Using the prefix kilo, kilometer. What was the answer of 6 km kilometer? Good, good. 6.0 kilometer. Okay, that was wrong. 60 kilometer, no, 6.3 kilometer. 6 kilometer. Get it? 60 kilometer. 60 kilometer. And then third question, use exponential notation. Use exponential notation to express 4.22 mg in gram. Use decimal notation to express 4.22 mg in gram. Use exponential notation. Use exponential notation to express 2.22 mg in exponential notation. Milligram. Exponential notation to express 4.22 milligram in grams. Milligram. Milli. नीचे milligram. 4.22 milligram. 4.22, तो इसका आंसर होगा 4.22 into 10 to the power 3 मी मिली सेंटीमिली ग्राम. They use decimal notation to express. डेसिमल क्या होता है? ओ. mg in grams. So grams, mg, milli, 3, 0.00422 gram. Okay, that's also correct. You understand the idea basically. This is the decimal when you represent it in a, like, use this method, and when you express by the expression this. Okay. Temperature. Now what we mass and length. What we have learned right now, mass and length. Okay, now temperature. Temperature, a measure of the hotness or coldness of an object, is a physical property that determines the direction of heat flow. It's a physical property that determines the direction of heat flow. Heat always flows spontaneously from a substances at higher temperature to one at lower temperature. Thus, we feel the influx of heat when we touch a hot object, and we know that the object is at a higher temperature than our hand. Okay, the temperature scale commonly employed in science are the Celsius and Kelvin scale. The Celsius scale was originally based on assignment of 0 degrees Celsius to the freezing point of water and 100 degrees Celsius to the boiling point at sea level. Okay. The Kelvin scale is SI temperature scale, and the SI unit of temperature is the Kelvin K. 0 on the Kelvin scale is the lowest attainable temperature. Lowest attainable temperature, lowest attainable जो आप attain कर सकते हैं, okay, like practically possible temperature is minus 237.115 degrees Celsius. Referred to as absolute zero. The Celsius and Kelvin scale have equal size unit. The Celsius and Kelvin scale has equal sized unit, that is a Kelvin in the same size as a degree Celsius. Thus the Kelvin and Celsius scales are related according to Kelvin is equal to degree Celsius plus 273.15. Huh? The freezing point of water 0 degrees Celsius is 273.5 Kelvin. Okay. Notice that we do not use our degree sign with temperature on the Kelvin scale. ठीक है. Okay, so when we are learning about a temperature, where temperature is a measure of the hotness or coldness of an object. So it's a physical property to determine that the heat flow, direction of heat flow. So basically, and the fundamental law says the heat flows to hotter side to less hotter side, like from hot to cool side. Okay, high temperature and warm at lower temperature. Thus, we feel the influx of heat when we touch a hot object. Yeah, that's why we influx the heat touch a hot object. And we know that the object is at higher temperature than our hand, definitely. And then temperature scale commonly used employed in science are Celsius and Kelvin. So basically, Celsius is a based on a water freezing point and boiling point to the 0 degrees Celsius or freezing point and 100 degrees Celsius the boiling point of a water. This is a Celsius scale, and other than the Kelvin scale is a scale where Kelvin scale where um okay Kelvin scale where uh, the temperature, the lowest attainable temperature, like minus 275. What was the 73? Minus 273.15 degrees Celsius. This is called absolute zero, as absolute zero temperature. Okay, Celsius and Kelvin scale are equal size unit, that is a Kelvin is the same size as a degree Celsius. Thus the Kelvin and Celsius scale are related according to Kelvin is equal to degree Celsius plus 273 plus 273.15 de- 273.15. Okay, the freezing point of water is 0 degree Celsius, and the freezing point of water in Kelvin is 2.73.1 273. I'm good. 273.15 KS. Notice that we do not use a degree signs with the temperature on the Kelvin scale. Definitely, it's Kelvin scale. The common temperature scale in the United States in the Fahrenheit scale. Okay, now there's new one. The common temperature scale in the United States is a Fahrenheit scale, which is not generally used in science. Water freezed at 32 Fahrenheit and boiled at 220 Fahrenheit, 212 Fahrenheit. Water freezed at 32 Fahrenheit. Water freezed at 32 Fahrenheit and boiled at 212 Fahrenheit. 212 Fahrenheit. The Fahrenheit and Celsius scale are related according to degree Celsius is equal to 5 by 9. 5 by 9. Degree Celsius is equal to 5 by 9 into degree Fahrenheit minus 32, or Fahrenheit is equal to 9 by 5 degree Celsius plus 32. Huh. So degree Celsius is equal to Fahrenheit is equal to 5 by 9 degree Celsius is equal to 5 by 9 Fahrenheit minus 32 Fahrenheit minus 32, or maybe Fahrenheit is equal to 9 by 5 9 by 5 degree Celsius plus 32. True or false? The size of a degree on a Celsius scale is the same as the size of a degree on Kelvin's weight. True or false? The size of a degree on a Celsius scale is the same as the size of a degree on Kelvin scale. Yes, that's true. Converting unit of temperature. A weather forecaster predict that temperature will reach 30 degrees 31 degrees Celsius. What is the temperature in Kelvin and in Fahrenheit? So basically 31 plus 2 7 3.15. How much? 273.15. So 73 plus 31. 74 to 7304.15 degrees Celsius, and in Fahrenheit, what was the Fahrenheit temperature in Kelvin? 5 by 9 क्या था? तो ये 31 5 by 9, और ये क्या था? Fahrenheit, डिग्री Fahrenheit minus 32. So 1 degree Fahrenheit is equal to 9 by 5, or 31 minus 32. तो ये 1 होगा, is equal to 9.5 into 1. 304 K. 304. ये तो सही है. डिग्री सेल्सियस नहीं लिखेंगे, केल्विन लिखेंगे. सो यूजिंग इक्वेशन 1.2 we have Fahrenheit 9/2. अरे भाई दिस इज प्लस है, तो ये गलत हो गया तेरा. ओके. 9/5. 31 और 32 क्या होता है? 336. 63. 63. 9. Ethylene glycol. Ethylene glycol chemicals are ingredient in antifreeze. Freeze at minus 11.5 degrees Celsius. What is the freezing point in Kelvin and Fahrenheit? So basically, 273 minus 11.5. 273 में 11 का टाइम मतलब कितना होगा? 268, 69 something. 261. Oh yes, sorry. 61. And what is in point Kelvin? फ़ारेनहाइट में क्या करना है? फ़ारेनहाइट में कैलकुलेट करना पड़ेगा. SI unit. The SI based unit are used to obtain SI derived unit. SI based unit are used to obtain derived unit. To do so, we use the defining equation for the quantity, substituting the appropriate base unit. For example, speed is defined as the ratio of distance traveled to elapsed time. Elapsed time. Thus, the SI unit for speed SI unit speed M1 is read meter per second. Meter per second is a derived unit. The SI unit for distance length m divided by the SI unit of time s. Two common derived units in chemistry are those for volume and density. Volume and density. Okay. Based on obtained derived units, derived SI units. So do we use the defining equation for the quantity, substituting the appropriate base unit. For example, speed is defined as the ratio of distance traveled by elapsed time. Speed Speed is defined as the ratio of distance traveled to speed is like ठीक है ratio of distance traveled elapsed time. ठीक है this the SI unit for speed is meter per second. Meter per second read meter per second is a derived unit. Meter per second distance varied by the SI unit for time. Two common derived unit in chemistry are those for volume and density. Okay, volume. The volume of a cube is its length cube. Volume of a cube is its length cube, length to the power 3. Q, Q, Q. 1, 2, 1, 1, 2, 1, 2, or 3. Hmm. Okay. The volume of cube is in length cube. Thus, the derived SI unit of volume is the SI unit of length. M raised to the third power, the cube meter, meter square, meters, not m to the power 3 is a volume of cube that is 1 meter on each edge. Smaller units such as centimeter, centimeter, cm square, sometimes written cc, are frequently used in chemistry. Another volume unit used in chemistry is the liter, which equals a cube's decimeter. D, and is slightly larger than a quart. The liter is the first metric unit we have encountered that is not an SI unit. There are 1000 milliliters, ml in a liter, and 1 ml in the same volume in the 1 centimeter square. Okay. So now here's my confusion start. That's the only thing which, you know, I think this is the only my obstacles in chemistry that till now I didn't understand this SI marking and the calculation, the meter square, and the worst thing then when it comes onto molarity and molality, mole counting and everything. Yeah, but I think I'm gonna like yeah, I'm gonna do it this time. Do I sound very dumb that I don't know this thing? These are very basics in chemistry. Actually, I knew it, but it's been 4 years now. I forget it that I'm not very much in memorizing things. So yeah, I used to remember all those things when I was doing chemistry and all those calculation things, but I didn't like it very much. But I miss those things now. Why do I talk too much? Just study. Okay. You know what? I will, but I remember something and I have to go. But I'll come back very soon. Something is wrong. Ah, okay.